Section 3.6 is talking about derivatives, and you'll find out why we're talking about this in a little bit. Derivatives are actually an interesting subject. But first of all, we have to lay down some initial information before we get to talking about a derivative. First of all, I want to make sure we understand what a tangent line. A tangent line is a line that intersects a curve at one and only one point. So if I have a curved line like this, its tangent line is something that comes and hits this curve at exactly one point. It gets really, really close, hits it at one point, and then it never hits it again. So that's what a tangent line is, all right? What a secant line is a line that intersects a curve more than once. So it might intersect a curved line from here to here, so it hits it twice or more than one time. That's a secant. All right, so the secant is the top guy, the tangent is the bottom one. What a derivative is, a derivative gives you the equation to find the slope of a curved line at any single point at that line. Would you agree that the slope of a curved line changes rapidly? It changes continuously. All right, so the biggest one we can think of is, let's think of our y equals x squared graph. All right, it starts at 0, then it goes up 1 over 1, right? Up 1 over 1, and then it goes over 2, up 1, 2, 3, 4, right? Now, if you look at this guy's slope in intervals, that interval is always changing, that slope is always changing in different intervals, all right? It's getting steeper. Now, look at this. We have a point 0, 0. And so in the interval from this point 0, 0 here to the point 1, 1, we can find that guy's slope. Well, that slope is the y minus the y, so 1 minus 0 all over 1 minus 0. It's up 1 over 1, right? Well, look at this. I have the point 1, 1, and now my slope is going from the point 1, 1 to 2, 4. And I want to know the slope of that, 2, 4. All right, so let's say we can do the y minus the y, so y minus 4 minus 1 divided by 2 minus 1, right? y1 minus y2 x2 minus x1 would give us a 3 over 1 slope. Well, wait a minute. That changed. You know that when we had a regular graph, so like we had the equation y equals x plus 1, we knew that that slope was continuous all the way. It went up 1 over 1, up 1 over 1, up 1 over 1. It always had the same slope. But when we get into different functions and actually ones that are curved, their slope changes all the time. That's why they are curved, and it's not a straight line, right? So their slope changes all the time. So now with a derivative, we can find its instantaneous rate of change, or what's the neat application of derivatives is this instantaneous velocity. It's instantaneous rate of change. The best way I can describe a derivative is what you guys know now is if you are driving in your car and you go from point A to point B, and that's 60 miles, and it took you 1 hour. So you guys say that, oh, I went 60 miles per hour. Well, you know when you start your car, you're not going 60 miles per hour, and it takes you time to get up to 60 miles per hour. And then when you come to a stop, all right, you are below 60 miles per hour. You know that you didn't go 60 miles per hour that entire time. And what a derivative is pretend like you're driving and you look right down at your speedometer and it tells you exactly how fast you're going. That's your instantaneous rate of change. It's your instantaneous velocity, how fast you're going at that exact moment. And it's probably going to be, if you went 60 miles in 60 minutes, you're probably going faster than 60 miles per hour at some point during that trip. And actually, there's a thing in calculus that says you're guaranteed to go that far, or you're guaranteed that you're going faster than 60 miles per hour. But you'll get to that next year anyway. But that's what a derivative is. Okay, so I'm going to show you how to find derivatives. But first off, I'm going to try to relate some information that you already know. All right, so we know that if we're given a function and they tell us to find f of 3, we know that in this function f, we're going to plug in whatever it says in this parentheses here. So wherever we see an x, we're going to plug in a 3. So it's going to be 2 times 3 plus 8. Well, that's f of 3. So then we say 2 times 3 is 6 plus 8 is 14, right? And again here, if we want to know what f of f of 2 is, instead of having an x, we replace it with, anywhere we see an x, we replace with a 2. So f of 2 is equals 2 squared minus 10, right? All right. Well, the same thing applies if I write x plus h, or if I write Mr. J, or if I write one of your guys' names. Anywhere you see x, I'm going to replace it with whatever's inside this parentheses, and anywhere I see an x, I'm going to replace it there. So anywhere I see an x, I'm going to replace x plus h squared, and then I'm going to add 2 because that's what this function says. And all it is saying rewrite this function with x plus h in it instead of an x. So you rewrite it with x plus h, everything else stays the same. Why is that important, you're asking? Well, because I have a formula here to find a derivative. And this is saying the slope of the tangent line with points x, f of x, and so forth is this. And we talked about limits a little bit in that last section, and they're going to come in handy again in this section, and I'll show you here in a little bit. But here it gives us the equation. It says take the function, and instead of x, we're going to replace the x's with x plus h, and then we're going to subtract the function with just x's in it, and we're going to divide it by 0, and we're going to take the derivative, or the limit, as h approaches 0. All right? And so what we're doing is what we have here, the definition of derivative comes from, if I have any curved line like this, any curved line, what they're saying is we want to know the slope of this line right here. Well, what we know so far is that we know that we can find a slope between 2 points. We can find its average rate of change, right? Well, if we move this point closer, we're going to get closer to its its instantaneous rate of change, but it's still an average rate of change. And again, if we keep moving it closer and closer and closer and closer, and that distance that we're moving, we're calling it h. All right, so this distance between these secant lines. All right, so if I wanted to find a slope here, I connect it with another point down here. This distance is h. Well, as this distance get closer and closer, we're going to change that distance over here. This is going to be h again. Well, as h approaches 0. So basically, when this line, as we get closer and closer and closer and closer to the point that we're trying to find the slope at, that's what a limit is. So we're finding the limit is the distance between our two secant points. We're finding the limit that as it approaches 0. So as it comes and gets really, really close to that point right there, is going to tell us the slope of our curved line at that very point. All right. So they're asking us to find the slope of the tangent line to the graph f of x equals 3x squared minus 4x plus 1 at 2, 5. Well, all right, what they're saying by find the slope of the tangent line, they're saying find the derivative of this function. All right, so find the derivative of this function. And we were given the equation right up here, so we're going to say the limit as h approaches 0 of f of x plus h. So that means we're going to rewrite this function here. Instead of x's, we're going to rewrite it with x plus h. So it's going to be 3 times x plus h squared minus 4 times x plus h, because we're replacing the x's with x plus h, plus 1. So that's that entire function. So we took care of that part. And then we're going to subtract, they said, subtract the original function, 3x squared minus 4x plus 1. All right, and then they say, and then divide by h. We're going to take the limit as h approaches 0. If we were to plug in 0 right now, we noticed in the last section we plugged in 0 at the end, and the reason we had to plug in 0 at the end is because if we plugged in 0 right now for our limit, if we made h 0, we'd be dividing by 0, which is impossible. So basically what we have to do, you can't divide by 0. So what we have to do is we have to go ahead and expand and simplify this, and things are going to cancel out. And then once we're all done canceling, then we're going to plug in 0 for h, and we'll find our derivative. All right, so we're going to have to square this out. We're going to have to distribute, and then distribute that negative sign. So let's work up on top here. X plus h squared, if you remember your shortcuts from algebra, it's this term squared, which is x squared, or you can just FOIL it out, which would be x plus h, right? Same thing. So that term squared, multiply these two and double it, so it would be plus 2xh. And then you square the last term, plus h squared. And we said that now we have to distribute that 3. So up top we're going to have 3x squared plus 6xh plus 3h squared. And all I did is I took this 3 here, I squared this out, and then I distributed my 3 through because that's what my equation says. And then we're going to subtract then. Here it says minus, and we're going to subtract, or let's distribute a negative 4 through this guy. Distribute a negative 4, so I get minus 4x minus 4h plus 1. And then we're subtracting, and we can just change all these signs. So this would be a minus 3x squared plus 4x minus 1. And I kind of ran out of room there. I should have wrote smaller. And that's all over h. The nice thing about derivatives is these things over on this side over here on the left side, they're always going to cancel out with, on the right side, these are always going to cancel out with something over here on the left side. So notice that I have a negative 3x squared here and a positive 3x. That's going to cancel out. I have a positive 4x here and a negative 4x here. That's going to cancel out. I have a minus 1 over here and I have a plus 1 over here. Those guys are canceling out. And all we're doing is we're adding like terms that are going to cancel out. So what we have left over is we have 6xh plus 3h squared minus 4h, and that's all over h. So there's two ways to look at this now. We still have a limit, by the way, as h approaches 0. We still can't plug 0 in for h because it would make this undefined. We can't divide by 0. So what we have to do now is we have to continue to simplify. If you notice, these all have h's in here. We can pull an h out and say this is 6x plus 3h minus 4 and divide by h. And now since this is multiplication, we can cancel out diagonally. All right, or in this case, we wouldn't have had to do this step. If you notice, each term has an h. We have to take an h out of every single term, not just one term. So that becomes a 1h, and this becomes a 4. So what we have left over is just now what's inside here. So we're taking the limit as h approaches 0 of 6x plus 3h minus 4. And now this is where we finally can plug in 0 for h because it's not going to be in the denominator. It's not going to make the function undefined. So when we plug 0 in for h, we have 6x plus 3 times 0, which is 0, minus 4. And this is our derivative of that function. So we found the equation of the function that'll give us our derivative, our instantaneous velocity, or slope of the tangent line at any point. Well, they just so happen to want us to find the slope of this line at x equal to 2. So I'm going to plug 2 in for that x, and I get my slope at 2, 5. So 6 times 2 minus 4 is 12 minus 4, which is 8. So at that very point, at 2, 5, at x equal to 2, the slope of that equation, the slope of this curved line, is 8 over 1. All right? Now, I'm going to stop here, and I'm going to put this other part in a different video on the next page.